So now that we can classify by degree, we know what standard form is, we can classify by degree and number of terms. We know what leading coefficient means and how to add and subtract and multiply. Let's move on. When a polynomial is factored completely into linear factors, now, what does a linear factor look like? Factors always look like this. X minus a number. X minus a number. Now, I know what you're going to tell me. You're going to say, Mr. Stailey, I don't agree with you. Factors don't always look like that. Sometimes they say X plus. Well, what happens if the number that I put in there is a negative number? Well, then that would change it and it would look like X plus. Now, there are a few variations on that. I see one coming in part A. Okay, so we're going to talk about that. But factors are always like X plus, X minus, unless the coefficient of the X term is not a 1. If it's something like a 2 or a 3, I see 1 coming in example 1A, which is a 3. When they ask me to write it in standard form, guess what I have to do? I have to FOIL it together, right? And so now we have 3 things. Now, I don't care which 2 you start with. It really doesn't matter to me. Now, for some of you that want to save space, you could put your box underneath one of them and take the one right next to it and put it on the side. So I'm going to be multiplying those 2 things together. So I have 3x squared, 4x, 15x, and 20. So what do I get out of that? I get 3x squared plus 19x plus 20 times, carry this one down because I didn't use it yet, x plus 10. Now, I could have just as easily taken the first 2, multiply them together, and then multiply by the last one. It literally does not matter which one you use. And now you can see that what I'm doing is I'm putting my next box directly under this trinomial, and I'm taking this one and putting it on the side. And now I can match up everything inside that box, right? 3x cubed, 19x squared, 20x, 30x squared, 190x, and lastly, 200. And so now I can multiply these things together and get 3x cubed plus, now these 2 get added together, 49x squared plus 210x plus 200. Now, did they ask me to do anything more than that? Nope, they did not. Now, is there a way that I could have figured out the first term and the last term without doing all of this work? The answer is yes, and I want to show that to you now. What happens when you take x times 3x? X times 3x. In other words, what I did was I multiplied the firsts together. What did I get? I got 3x cubed. So, it's easy to tell the first term. Now, how can I do a similar strategy to find the very last term? Well, 10 times 5 times 4. So what is 10 times 5 times 4? Well, 10 times 5 times 4, that's 200. So that's the lasts. We multiplied all the lasts together and we got 200. Ding, 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 ding. Okay? So it will come in handy in the future to know what the first terms would multiply to be, and it will come in handy to know what the last terms would multiply to be. I just need you to be able to do that in the future, so I might as well talk to you about it now. Okay, so here's another example. Now, before you do this example, I'm going to suggest that you write out all three of the terms. Remember, what does x minus 2 squared mean? It means x minus 2 times x minus 2. Okay, take your favorite pick, whichever two you want to start with. I think I'm going to start with these last two, write this one down the side, and now start multiplying things together. X squared minus 2x minus 2x and a plus 4, giving me x squared minus 4x plus 4. And now I'm going to multiply that by the one that I skipped at the beginning. All I'm doing is using a bigger box, folks. X cubed minus 4x squared plus 4x squared minus 16x and a plus 16. And so then I can give you x cubed. Oops. I see those cancel out. And then I get a minus 12x and a plus 16. So anyway, x cubed minus 12x plus 16. You could use the same trick like I showed you before to come up with the first term just by multiplying x times x times x, right? You can use the same trick I talked about, 4 times negative 2 times negative 2, right? And so that gives me 16. That's something I want you to have in the back of your mind because we are going to talk about it, just not right now. Okay, write a polynomial in factored form, factor each of the polynomials completely. Okay, we always know that we look for a greatest common factor when we start these things. In fact, I see an x that I can pull out of all of them. X squared minus 6x plus 8. Now remember what you're doing when you're factoring. Let me back up. Remember, when we say that we are factoring, factoring is a fancy way to say division, right? So we're dividing those, and that's how you know x squared minus 6x plus 8. But you ain't done yet because you have to keep going, right? Remember, we talk about things that multiply to 8 but add up to negative 6 and all that good stuff. And so we would have x minus 4 and x minus 2. And so we end up with something like this. All right, so that's completely factored. It's got all the factors in it exactly the way we want. Now, what's the GCF over here? Now, you don't always get a GCF, folks, but we do end up with, in both of these examples, there's a GCF, and we got to start with that. So we have got to, let me just drop it down a little bit farther so I can remind you about the division, right? We're dividing each one of those by x squared, which the first one would leave us x squared and the second one would leave us minus 25. Now, I see a difference of perfect squares, right? Which we have talked about before, a difference of perfect squares. And how do we factor that? Well, we leave the x squared on the outside, but then we're breaking up the parentheses. And let's see here. Obviously, the basic idea is you take the square root of this one and you take the square root of this one, and we got a plus and a minus. So that's pretty straightforward. X and x, 5 and 5. And that's as factored as it gets. You can't break it down any more than that. Okay? We pulled out the greatest common factor. We saw the difference of perfect squares, and so we kept the train rolling, so to speak. All right, next screen. 0 root, or you can also think of it as an x-intercept, unless, of course, it's imaginary, because then it means it won't hit the x-axis. But But yes, an x-intercept is the most common thing that we think of as a zero, but any solution would be what we call a zero or a root. And so truly, it means you're just solving for x. If it's real, it would be where it crosses the x-axis. And the number of zeros, that's equal to the degree of the polynomial. If we assume the number of zeros, no, if we count the multiplicities, let's just be specific. Count the multiplicities. Okay. You don't know what that term multiplicities means, but we're going to talk about it here. So if I said to you x minus 2, then we would know that that factor occurs one time, and so we would say that it has a multiplicity of 1. But if we see x minus 2 occurring 2 times, we would say the multiplicity is 2. Or if we saw the x minus 2 3 times, we would say the multiplicity is 3. So in other words, this is the number of times it occurs as a factor. Sorry, it almost looks like occurs as one word, but. And where did we see all of those? The exponent. So the exponent tells you the multiplicity. That makes it a whole lot easier, but it has to be in factored form for you to see that. So if we want to identify the zeros, first we have to have it in factored form, and it has to be set equal to 0. Is it true? Is this in factored form? The answer is yes, it's in factored form. This problem is practically gift wrapped for you. So if I gave you this chart and I said zeros and multiplicities and I asked you to fill it in, remember we set the factors equal to 0 and we solve them. Okay? Now the first one would be 3x equals 2. You would divide by 3 and tell me that the 0 is 2/3. Now how many times do you see it as a factor? Look at the exponent. The exponent is a 1, so that multiplicity is 1. Now, I'm going to teach you eventually what multiplicities do on a graph. Right now, I just need to know how to find them. X equals -2 would be your next one, but I can see that that occurred 4 times. Nobody wants to write 4 of those things out. But that's what it is. Now notice I did not ask you to multiply this all together. I mean, who in their right mind wants to multiply 3x minus 2 times x plus 2 times x plus 2 times x plus 2 times x plus 2? Nobody wants to write all that out. I didn't ask you to FOIL it all together on this question. I just asked you to basically fill in this chart. So let's do it again. We got zeros. We got multiplicities. So we're setting these equal to 0 and solving them. So obviously this one would be -5/2. The exponent that I see there is a 1. The next one, pretty easy. Set it equal to 0 and solve, so -6, but it occurs 3 times. The next one's x minus 7. That's obviously 7, and it occurs twice. You can see the exponents. Okay, last one. Now this one I'm a little bit worried about how this one's not factored. At least this part right here is not factored. it has to be broken up into x plus 8 and x minus 8. That's a difference of perfect squares. So what we're trying to show you is that in the near future, you're going to have to do factoring, and then you're going to have to tell me what the zeros are and the multiplicities. So let's see what the zeros are. Fill in our little chart here and the multiplicities. Now, am I worried about the x plus 8? Because you'll say negative 8 and it occurs once. Am I worried about the x minus 8? You'll say positive 8 and once. Am I worried about the x plus 5? You'll say negative 5 and you'll say once. No, I'm not. Am I worried about the negative 2x squared equals 0 at the beginning? Yeah, because you guys make major mistakes with that all the time because you never listen to when you set it equal to 0 and solve. You get this, you kind of try to do these shortcuts in your head and you're like, oh, x plus 8, that's negative 8. X minus 8, that's 8. X plus 5, that's negative 5. And then you get to this last one and you're like, what the heck is that? And you write down crap like negative 2. That's not true. It doesn't say x plus 2. But you should be dividing by negative 2, which would give me x squared equals 0, right? 0 divided by anything is still 0. And then, of course, you're going to take the square root of both sides. So that says x equals 0. So it crosses through the x-axis at 0. Now, how many times does it do that? Remember, you pay attention to the exponent. So I would be expecting you to put a multiplicity of 2. That one right there is the one I'm always worried about because kids don't listen to what I'm saying. And so then they get to the test, they get to that question, they don't pay attention to it, boom, they're writing down negative 2. I don't know. Sometimes they might put multiplicity 2, but they never get the right 0. Anyway, so that one you need to be careful with. On example 4, it says write a polynomial. Now, key thing right here is that kids need to pay attention to where it says factored form. Nobody said multiply it all together. Not a single person said multiply it all together. Everybody just said write a polynomial in factored form. Okay? Now, to be a polynomial function, we would have to be y equals. Okay, so we are going to have to start off with y equals. For 4, right now, if you don't know how to do this, set x equal to 4 and move it over, and what you will see, so this is kind of the opposite process, you will find the factor is x minus 4. So, same thing would happen if you had x equals negative 3. Move it over, you get x plus 3 equals 0, so you see the factor is x plus 3. Same thing, x equals 2. Now, some of you are probably looking at me going, why would I write that out, Mr. Stailey? I know that it's x minus 4, x plus 3, and x minus 2. I know, but when I get to the next example, I'm worried. So I do know that we're going to start off with y equals. Am I worried about this one? No. You're going to come up with x minus 3. Am I worried about the last one? Yes, because you're going to say something like x equals 2/5, but instead of, now this is where it comes into play here, leading coefficient of 1, no fractions. Wait a sec, find the given zeros and a leading coefficient of 1. I guess they do want me to do that. I was not expecting that. I don't really want to do that. If we wanted to do that with a leading coefficient of 1, it would say x minus 2/5. But if we wanted it to be, how about we say integer coefficients. This is more likely, folks. I don't necessarily need a leading coefficient of 1. I do need leading coefficients, which are integers. So how would that be changed on this? Well, I would multiply it by 5. And if I do that, I would get 5x minus 2. This is what I am wanting. 5x minus 2, not x minus 2/5. Now, am I worried about what you're going to do with the first one? Yes, I am. Yes, I am. I want plain old x. Plain old x. People screw that up all the time. All right, what about the next one? Well, see, we could do this whole x equals negative 1/2. We could multiply both sides by 2 and get 2x equals negative 1, and then we could move that to the other side. So we could start out y equals 2x plus 1. That's where the negative 1/2 comes from. Now, the 9. I know, you know that that's x minus 9, but then it says this with a multiplicity of 2. So they just told me to put a square on it. Okay? So that's how you handle A, B, and C. Example 5. Find the zeros of each of the following. State the multiplicities as needed. Okay? I guess they're assuming that a multiplicity of 1 is not necessary. I'm like, well, we need to know what it is. So always look for a GCF to pull out. And so I see that every one of those terms has an x to the 4th, which would leave me with x squared minus x minus 12. And then I can go further with that. Because I know things that multiply to negative 12 but add up to negative 1. So that would be x minus 4, x plus 3. So if I were to make my little chart, zeros and multiplicities, of course we would have 4 occurring once and negative 3 occurring once. What about the one at the beginning that I'm always worried about? 0 occurring 4 times. Remember, that's the one when you set it equal to 0 and solve, you get 0. Not 1. Kids say 1 all the time and mess that up. Okay, next one over. X cubed. Factor it out, leaving me with x squared minus 49, which is a difference of perfect squares. So 0 equals x cubed. This is where we take the square root. One's a plus, one's a minus. And now we can fill in our table. So we've got the 7 occurring once, we've got the negative 7 occurring once, and please keep in mind that 7 comes from this one, and that negative 7 comes from this one. You set the factors equal to 0 and solve, and then this one obviously is the 0 that occurred 3 times. And now we got our last one here. Factor out a 2x, giving me 1x squared minus 6x and a plus 9 equals 0. And of course we can continue this process of solving, thinking of things that multiply to 9 but add up to negative 6. Of course that would have to be x minus, and the only combo that works would be 3 and 3. Now, when you go to make your chart, remember zeros and multiplicities. Right, so the 0, well, that's easy. That occurred 1 time. But the 3 occurred 2 times, right? You see x minus 3 happened twice. You can see it how it happened twice. think that's the end of this lesson. Let me check. Yep. See you on the next one.